Hi everyone. Alright, here's the practice test, test 11. And I've got two functions that we're going to use for this whole page. F of x and g of x, and it's going to be used in this whole page. And f of x is x squared plus 3x minus 2. G of x is x plus 5. To find f plus g of x, I got to take f of x plus g of x. F of x we're looking at here is x squared plus 3x minus 2, and g of x is equal to x plus 5. So I'm going to put plus x plus 5. And when I go to simplify this, I can look at it without those parentheses. I've got the x squared. That's the only x squared. I got a 3x here and a 1x here. 3x plus 1x is 4x. And I have negative 2 and positive 5. So I'm getting positive 3 there. Now g minus f of x. So I take g of x minus f of x. And g of x is x minus 5. F of x is x squared plus 3x. Whoa. Okay, let me reboot that. I got x minus 5. Now it's minus x squared plus 3x minus 2. So this is x minus 5, and then I'm going to distribute this negative, minus x squared minus 3x, and then a minus and a minus is a plus, so that's plus 2. This is x plus 5. I got to be careful here. All right, I'm working at being careful now. That was x plus 5. That should not have been x minus 5, because that's just that. All right. Now, there's my first term. I'm going to write the negative x squared first. Then the x terms x and minus 3x, that's negative 2x. And then 5 plus 2, that is plus 7. I think I may have checked somebody's along the way, and it wasn't quite this answer, but I'm pretty sure this is correct. All right, this number 3 is f times g of x, and that's f of x times g of x. So I'm going to take the f of x, which is x squared plus 3x minus 2, and I'm going to multiply it by the g of x, which is x plus 5. Okay, so I'm going to just multiply each term in here by x. X squared times x is x to the third. Whoops. And then I'll take the 3x times x, that is 3x squared. And then I'll take the negative 2 times x, and that's negative 2x. And then I'll take each one of these 3 by 5. So 5 times x squared, that's plus 5x squared. 3x times 5, that is plus 15x. And negative 2 times 5, that is negative 10. And this equals x to the third. I got 3x squared and 5x squared making 8x squared. I got negative 2x plus 15x. Negative 2x plus 15x, that's positive 13x, and then this minus 10. All right, number 4. This just is f of x over g of x. F of x is x squared plus 3x minus 2. G of x is x minus 5. And unless you can factor, which I don't think you can on this one, you wouldn't be able to simplify that anymore. Just leave it like that. Now, the restrictions. X minus 5 is in the denominator. And x minus 5, a denominator cannot be 0. So when I add 5 to both sides here, that means x cannot equal 5. So here is the simplification, f of x over g of x. Here is the restriction. Now f of g of x, this is composition of functions. What we're going to do is we're going to put the g of x function inside the f function. Well, the g of x function is x plus 5. And the f function says we'll replace the x's, all these x's, we're going to replace with x plus 5s. So I'm going to take the x out, put x plus 5 in its place, so I got x plus 5 squared, plus 3, take the x out, put x plus 5 in its place, and then minus 2. There's no x on that, so that just stays like that. Now, x plus 5 squared, that is, I'm going to write this out, x plus 5 times x plus 5 plus 3 times x plus 5 minus 2. Let's FOIL this out. X times x is x squared. Outside, that's 5x. Inside is 5x. And 5 times 5, that's 25. 3 times x is 3x. 3 times 5 is 15. This negative 2 is just out by itself. It's not being multiplied by anything. I have an x squared. I got a 5x plus 5x is 10x plus 3x is 13x. I got a 25 plus 15, that makes 40, and 40 minus 2, 40 minus 2 is 38. So that's what I get for f of g of x, that composition of functions. Now this is doing it the other way around. G of f of x. I'm going to put the f of x function inside the g function. That's g of x squared plus 3x minus 2. I'm going to replace the x with x squared plus 3x minus 2 in the g function. So I'm going to write x squared plus 3x minus 2 plus 5. Here's what was in for x. I've replaced it, and then I had the plus 5 over here. And that is x squared plus 3x, negative 2 plus 5. Negative 2 plus 5 is 3. So that's g of f of x. Now number 9 is really all we need to do is look at that function. G of f of x is equal to x squared plus 3x plus 3. G of f of negative 4 will equal negative 4 squared plus 3 times negative 4 plus 3. And that is 16, because a negative times negative is positive. 3 times negative 4 is negative 12 plus 3. 16 minus 12 is 4. 4 plus 3 is 7. And then f of g of 2. Well, f of g of x is x squared plus 13x plus 8. So I'm going to put 2 in place of x. So I have 2 squared plus 13 times 2 plus 38. And that's 4 plus 26 plus 38. 30 and 38 makes 68. All right, there's page 1. Page 2. For 11 and 12, find the inverses of the following functions. Okay, so this I'm going to write as y equals 3x plus 1. I'm going to take the f of x out, put y in its place. And then, when I rewrite that, I'm going to have x equals 3y plus 1 for the inverse. Then I'm going to solve for y, or get y by itself. So I'm going to subtract the 1. I've got x minus 1 equals 3y. And then I got that 3 on there still, so I'm going to divide by 3. And I have x minus 1 over 3 equals y. Okay, I'm back here. Now, once you've done this, you switch the y to this notation, inverse of f of x. And that's equal to x plus, nope, x minus, let me write that over. X minus 1 over 3. All right, number 12, f of x equals x squared minus 2. So I'm going to do the same thing. I'm going to write y equals x squared minus 2. I'm going to switch and have x equals y squared minus 2. And then I'm going to solve for y. So let's add 2 to both sides so that that cancels. So I have x plus 2 equals y squared. And then I'm going to take the square root of both sides. When I do that, I got y here is equal to the square root of x plus 2. And I'll write the inverse function, or inverse notation here. Okay. Now, number 13, if f of g of x is equal to x, then they are inverses. And if g of f of x is equal to x, then they are inverses. So, let's figure out what f of g of x is. So I'm going to write it this way because I like it better this way. That's f of 1/4 x plus 3. And in the f function, I'm going to put 1/4 x plus 3. So I got 4 times 1/4 x plus 3 minus 6. Okay, it's 4x minus 6. This is in place of x right now. When I distribute, 4 times 1/4 is 1, so that's 4 times 1/4 x is x, plus 4 times 3, which is 12, minus 6. This is equal to x. 12 minus 6 is 6. This is equal to x plus 6. That is not equal to x. So these two are not inverses. You don't even have to do the other way around. If one way doesn't work, then they are not inverses. All right, well, let's check 14 here. F of g of x is equal to f of the square root of x minus 1, which is the square root of x minus 1 squared plus 1. square root and squared. You remember those canceling out? So that leaves me with x minus 1 for this part, plus 1. And x minus 1 plus 1 does equal x. All right, well, when you get one way to work, you got to check the other way. Okay, so let's check that. G of x squared plus 1 is equal to the square root of x squared plus 1 minus 1, which is the square root of x squared. Well, the square root of x squared is x. Okay, these two are inverses. All right. I saw the redundancy there. I'm going to just do the graph here first. Okay. You know, the typical square root function, the parent function starts at 0, 0, and then goes 1, 1, and then I think 4, 2, kind of goes like this, and 3, 9. Okay, that's the parent function, but we're going to transform it. We're going to move it 2 units right, remember that minus 2, and 3 units down. We're going to move it to right there. And I'm going to make a table. And I'm going to start at 2, because that is kind of the starting point of our function. And I'll put a few in, 2, 3, 4, 5, 6. Okay. And I'm going to take the square root of 2 minus 2. And I'm going to press this, and I press the arrow button that ends the radical, and then I'm going to subtract 3. And that is negative 3. And then if I hit second and enter, all I have to do, I just want to change the 3 here. 3 there. Oops, not there. That stays 2. The 3 is the first one there. And that gives me negative 2. Now if I put a 4 in this place, second, and whoops, I hit mode. Okay, put a 4 where that 3 was. Negative 1.6. Put a 5 in there. Negative 1.3. I'm rounding nearest tenth here. Put a 6 in. This one might have a good answer. Yep, that's negative 1. And it just keeps going. But 2, negative 3. I already had that one put down. 3, negative 2 is right here. 4, negative 1.6, a little less, a little below half there. 5, negative 1.3, a little above half way between those two. And 6, negative 1. So it kind of goes like this. All right. 16. Okay. It would be at 0, 0 if this 1, plus 1, and plus 4 were not there. So I am going to go negative 1. I'm going to go 1 unit left and 4 units up, 2, 3, 4 up here, and make the table based on that. I'll go negative 1 for x, and then increase, oops, negative 1, 0, 1, 2, 3, I'll stop there for now and just put that into calculator. Now I'm going to use negative 0.5 for negative 1/2, then put the square root in, and I'm going to put negative 1 in first, and then plus 1, hit that arrow to get out of the radical, and then plus 4. And when I do that, I get 4. I'm going to take the negative 1 out and put 0 in its place. I hit second, enter, 0. I'm actually going to delete this negative sign also. And there I get 3.5. I'm going to put 1 in place of 0 for the next value, and I get 3.3. I'm going to put 2 in place of the 1, and I get 3.1. I'm going to put 3 in place of there, and I get 3 there, so that gives me some points to plot. Negative 1, 4, 0, 3.5. Whoa. Yeah, that's right. 1, 2, 3.5. 3.5. 1, 3.3, just slightly below. 2, 3.1. And 3, 3. So it looks to me, and it just keeps curving down a little bit. It's not a very sharp curve at all, like that. But it will continue to decrease. It will not go up or anything. All right. Now, 17, the domain and range. Domain, that's what x can be. It looks like 1, 2 is the beginning point. So, I'm going to write it like this. I'm going to put 2, and then it increases. Now the range is y, and if this is the beginning point, this is the low point. 1, 2, 3, negative 3. To infinity. And then the domain here, the far left point, that is negative 1 on the x. And the range is negative 1. Now it goes down, so I'm going to go negative infinity. Nope. Okay, I'm thinking wrong here. That's negative 1 to positive infinity. X keeps going right. Negative 1 is the far left point. Now, the far low point, it keeps going down, so that's where I'm going to put negative infinity to its high point of 4, inclusive there. All right, 18. I'm going to rewrite. It's a square root, so I'll put the little 2 there. 81 is 9 to the second power. Now, a to the 8th to the second power, that's 8 times 2 is 16. B to the 10th to the second power. C to the 6 times 2 power. The square roots and the squares are going to cancel out. So I don't have the radical anymore. Square root square, I have 9. That square's going. A to the 8th, that square's going. B to the 10th, and that square's going. C to the 6th. And I forgot this negative sign here. Hey! That's all right. Got one more problem to do, and then I'm out of here. Okay, 5th root. Now with 32, take care. 32, now you might have to look for it, but 2 to the 5th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So I got 2 to the 5th. Now I need a 5th power for x to the 15th. So I'm going to go x to the 3rd to the 5th. I'm going to go y to the 4th to the 5th. And the 5th root of 2 to the 5th is 2. 5th root of this, the 5s will cancel out. That's x to the 3rd. And 5th root will cancel out there, y to the 4th. All right, there you go.